Hi everyone. Let's talk about probability. Probability is usually defined as the study of randomness, but for our purposes, probability is going to be the study of gambling. Okay? That gives us a better sense of where probability came from and what it's used for. Probability started back in the 1600s when two mathematicians, Blaise Pascal and Pierre de Fermat, started writing letters to each other, discussing how they could use math to describe random events and how they could use math to get an advantage in games of chance. Here's what they came up with. They said that probability should be a number, and specifically it's a number between 0 and 1, and it can be 0 or it can be 1. A probability of 1, they said, would be a way to describe an event that is certain to happen. Okay? Definitely will happen. A probability of 0 would be used to describe an event that is impossible, will never happen. And then probability could be any number in between 0 and 1, and the higher the number, the more likely the outcome. So how did they decide to calculate probabilities? Well, before we can do that, let's talk about how to describe a random event. We can use the term chance experiment to discuss the types of things we're going to be studying using probability. A chance experiment is any activity or situation in which there's uncertainty about which of two or more possible outcomes will result. Now that's really just a fancy way of saying something is happening and really we don't know what's going to come up. Okay, so that's chance experiment. In the study of probability, there are three very basic chance experiments that we use to learn about more complicated chance experiments. And those are flipping a coin. That's a chance experiment because we don't know whether or not heads or tails will come up. Rolling a die is a chance experiment because we don't know which of the sides will generally come up when we roll the die. And drawing a card from a deck of cards is a chance experiment because we're not really certain about which card will be flipped over each time. When we discuss chance experiments, the first thing we want to think about is the sample space of that chance experiment. A sample space is the set of all possible outcomes of a chance experiment. Okay? So let's look at a couple of sample spaces. So the sample space of a coin flip. To write out the sample space of a coin flip, we have to think about what are the possibilities when we flip a coin. The sample space is usually labeled S for obvious reasons, and we list the possible outcomes as a set. Well, when we flip a coin, we can have heads show up, or we can have tails show up. So the sample space of a coin flip is heads or tails, and we'll just note here that there are two outcomes in the sample space. What about for rolling a die? Well, any of the 6 sides of the die could show face up, and those sides are labeled 1, 2, 3, 4, 5, and 6. So the sample space of a die roll is 1 or 2 or 3 or 4 or 5 or 6. There are 6 outcomes in a die roll. What about for drawing a card from a deck of cards? Now, if you're unfamiliar with a deck of cards, go over some terminology. A deck of cards has 4 suits. Okay? Those suits are spades, which is the symbol here, hearts, okay, which is probably a little easier to see like that, clubs, and diamonds. Okay? And those are called the suits: diamonds, clubs, hearts, and spades. There are 13 cards in each suit. So 13 times 4 make a total of 52 cards. Okay? So the sample space of a card draw includes all of the cards. We could say there's the 2 of hearts, there's the 3 of hearts, okay, there's the 4 of hearts, okay, and we could just list out all of them. Okay, I'm not going to do that here to save some time, and I'll just note that there are 52 possible outcomes when we draw a card. Okay. After we discuss the sample space, what we're really going to be interested in are events, and we're going to be calculating the probability of events. An event is a subset of outcomes from a sample space. Okay. So if the sample space lists everything that could happen, an event is just one or more of those things that can happen. So, for example, an event could be of getting heads when we flip a coin. Another example of an event could be rolling a 5 on a die. Okay. These are simple events. They're just one outcome in the entire sample space, but we could put different outcomes together to form an entire event. So one example of an event like that is drawing hearts from a deck of cards. Now just note that hearts isn't just one outcome. There are actually 13 different outcomes that make up this one event, because there are 13 cards that have hearts as a suit. So how do we figure out the probability of an event? Well, if all the outcomes in a sample space are equally likely, then the probability of an event, E, is the number of outcomes in E divided by the number of outcomes in S. And we use the symbol lowercase p usually to represent probability. Okay? And this equally likely part of the definition is actually pretty important, which you can see with a couple of examples. Okay? So let's calculate some probabilities. What's the probability of tails on a coin flip? Well, our event is tails. Okay, so the event, the set, just has one outcome in it, tails. And let's just remind ourselves that the sample space of a coin flip, which we wrote down earlier, was heads or tails. So the probability, okay, now I'm assuming that heads and tails are equally likely. Okay, this is what you usually refer to as a fair coin, if heads and tails are equally likely. How do I know they're equally likely? I really don't. I'm making that assumption. So if heads and tails are equally likely, the probability is the one outcome in our event, tails, divided by the two outcomes in our sample space. So the probability of tails on a coin flip is 1/2. What's the probability of getting a 6 on a die roll? Well, our event includes one outcome, a 6. Our sample space, remember, was 1, 2, 3, 4, 5, or 6. So assuming that each side of the die is equally likely to come up, the probability is the one outcome in our event divided by the 6 outcomes in the sample space. What about the probability of drawing the ace of spades? Well, we can skip ahead here. I don't have to write out the event and the sample space every single time. Drawing the ace of spades, that's one possible outcome of this chance experiment. I'm going to divide that by the 52 possible outcomes in the sample space. Okay? Those were just 3 very, very simple and straightforward events. Okay, so let's look at some more complicated events. So what's the probability of getting a 1 or 2 on a die roll? Well, in this case, our event doesn't have just 1, but it has 2 possible outcomes, okay, getting a 1 or a 2. And the sample space still remains the same. It was 1, 2, 3, 4, 5, and 6. So the probability of getting a 1 or 2 on a die roll is the 2 possible outcomes in our event divided by the 6 possible outcomes in the sample space. So the probability is 2 over 6 or 1 over 3. Okay? And finally, what's the probability of getting a face card on on a card draw. For those who don't know, a face card in a deck of cards means either the jack, the queen, let's spell that correctly, and the king. And they're face cards because they usually have pictures of a jack, queen, or king on them. And a deck of cards has 4 jacks, 4 queens, and 4 kings. So our event has 12 outcomes. So the probability of getting a face card, which means getting a jack, queen, or a king, the 12 outcomes in our event divided by the 52 outcomes in our sample space. Okay, so let's see what can go into both 12 and 52. I know that 2 goes into both, so this would be 6 over 26. 2 goes into both of those, so 3 over 13. Okay, so the probability of getting a face card when we draw a card from a deck of cards is 3 over 13. Okay? Alright, have a good night.